Hey everyone, today we'll be going over 2.1.1. So we have a 50,000 that can be invested under two options. So we can deposit the 50,000 into a fund earning an annual effective rate of I. So with option 1, we can deposit this 50,000 with an interest rate of I, and we're just going to skip over the problem to see that they produce the same accumulated value at the end of 24 years. So that's our time, 24. Okay, and then now we have an option 2 where we have an annuity immediate with 24 level payments. So this is where we put payments, angle I. Oh, and it tells you I. This is 10%. And we have an unknown P. Okay, so the payments under option 2 are deposited into a fund earning an annual effective rate of 5%. Okay, so P, A 24, angle 4, or 10, sorry, that's not a 4, that's a 10% equals 50,000. Because that's what we started with, 50,000. And so we should divide by this annuity so that we can single out the payment. And so if we use our calculator, we have that 24 is our N with a 10% I, -1 payment, and we're going to calculate the present value. So it's about 9, and we want to divide that by 50,000. So we get that the payment equals 5,564.98. Okay, so let's read on more. We have that the payments are deposited into a fund earning an annual effective rate of 5%. So these payments, and these are every year, at the end of the year for 24 years. So we have 5,564.98 with an annuity of the accumulated function, and 24 with a 5% effective interest rate. So it's different from this one because this is to take the annuity immediate for the 50,000. We wanted to purchase it, so we would be calculating for the present value. But for option 2, we have the payments, and we want to see how much it accumulates to for 24 years. So that's where we got 24 and 5% from. So if we set this equal, because this is actually equal to the option 1. So we got option 1 here, which is 50,000, 1 plus I to the 24. And so for S, we have 24 N, 5I, 5,564.98 payments. And then we have to calculate the future value. And so with that, we divide by 50,000 to get 4.953 equals 1 plus I to 24. And then we got to get rid of this exponent, so we rooted by 1 over 24, just the reciprocal, to get 1.0689 equals 1 plus I. And so if we subtract that by 1 to get I, we get that it's 0.0689 or 6.89%. And that is the correct answer.